There we go. Present my screen. Alrighty. So you got 4 questions today. That is not the right one. Hold on. Yep, we're on this one. Here we go. We already did that one. Okay, so number 1, where is that star on the number line? So what number is that on? Number 2, there are 12 boys and 14 girls in your 6th grade class. I don't know if that, no, that's not true. Write a ratio to represent the boys and the girls related to the total number of students. So one ratio that's boys to the total, and then a second ratio that's girls to the total. Okay?
I thought we had a better than here.
One will be 14 and 12.
Yeah.
But you have both of them.
Yeah. So boys to the total, girls to the total. And then number 3, you're doing 6 divided by 4/5. And then once you get that answer, it needs to be in fraction form, decimal form, and percent. So you're going to go between fractions, decimals, and percents for number 3. And number 4 is simplifying. How else can you write 3 times 3 times 3 times 3? Think about that as exponents. I want you to write it as an exponent. Okay, so take 9 or 8 or 9 minutes to work on those 4 problems, please.
That walk outside that man's garden did not help him.
I'm sorry.
They were just walking. We saw him walking around.
All right, be working, please. Huh? Yeah, you guys just need to not play near that gate. All right, be working.
He was really open, you know, I just had this one on. I was thinking,
Make it or write it with an exponent.
oh, that's how you simplify it?
Yeah, simplify number 2. Yeah, that one just means rewrite it with an exponent.
That's easy. I already did it.
Okay, now do the other one.
I can do that one.
There you can.
I'm good. I'll do that one now. I don't even know how to pass this. Do I need this anymore? Oh, do I need this anymore, Mister? Miss Dove? Miss Dove? Can I get this one there? Did I get enough for you?
Yeah, sorry. Oh, you did.
Oh, no. I still don't get how to pass this grade without even knowing.
If it's working online, then no.
I should have got help that last year. What's that mean? Okay.
Your number is in between -1 and -2. Halfway between.
I don't know.
Well, if it's between -1 and -2, we know it's a negative, right? What number is in between 1 and 2? Like exactly in between.
Like what?
Yes, so it's a -1.
Yay.
Right, negative 1.
Now I need two more.
This is directly in between the -1 and -2, so that makes it halfway. 5 between -1 and -2. Right, the ratio, number of boys to the total in the class.
Number on here, number 4, number 5. So that's number 2. But it's number 4. Because number 1 is the 4 different class. I think it's number 1 and 2, so it's really yeah, it's like giving an answer.
Okay, about 3 minutes left.
I got a question about the divide one. How do you figure out how many things like how many numbers goes into the other number?
You can skip count, multiply, it's opposite of multiplication. This is how your ratio. So multiplication is or division is the opposite of multiplication. So you just skip count instead. To find out how many things it is.
Oh. The ratio only depends on that's how I am. Remember 12 and 14?
Well, no.
I'm not even gonna get it right. But yeah, no.
We're gonna review them.
I only got one other question.
So you're doing the number of boys is total. So how many boys are there? 12. So the 12 boys are there. Now you need to, when it says total, it means how many kids are in the class.
Oh,
I wrote my paper in here. So that's the boys. The total. Now you need to do girls. So that just, just write another ratio to that.
I can see.
And then if you can simplify, then you can. So if there's a number that goes in the house, colon 26, you can do that division.
I need some super glue over here tonight.
Okay, about 1 minute. All right. Let's go ahead and review these ones. So, let me stop the presenting, make this bigger. All right, can we see these problems? Are we all good? Nope. Pretty good? Okay, so let's start with number 1. We need to figure out where this star is. We are between -1 and -2. So if we just get rid of the negatives, first of all, just don't think about it as negatives. What number is halfway between 1 and 2? 1.5. 1.5, if you wrote it as a fraction, that's fine too. What do we need to add though, because it's in the negatives? A negative sign. So this is -1 and 5/10 or -1.5. And halfway between -1 and -2. All right. Number 2, this time we're writing some ratios. We're writing the ratio of boys in the class to the total number of students and the ratio of girls in the class to the total number of students. How many boys were there total? 12. And then how many students total were there? 26. You need to add together the number of girls in the class to the number of boys, and you get 26 total. But we need to simplify our ratio. Can I simplify 12, 26? What number goes into both 12 and 26? 2. So we can divide by 2. What is 12 divided by 2? 6. 26 divided by 2? 13. 6 to 13. So for every 6 boys in their class, there are 13 total students. Okay? And then we need to do the same thing for the girls. How many girls were there total? 14 girls total. And then how many total students? 26. And then we do the same thing. Simplify. Is there a number that goes into about 14 and 26? 2. What is 14 divided by 2? 7. And then we already did 26 divided by 2. It's 13. So for every 7 girls in the class, there are 13 students total. Yep. What do you notice about these two numbers, 7 and 6? Well, okay, compared to the ratios, I guess. Okay. Go take a lap around the school, fill up your water bottle. Well, then you can't tell me you're tired and then refuse to do what I asked you to do. Not how it works. What do you know about this total, the 6 and the 7, compared to the total number of kids? The 6 boys and the 7 girls add up to the total number of students that you see. Yeah. All right. Number 3, we need to do some division. We need to divide. I can't divide just yet because I need to change my 6. What happens to my 6? We need to put it over 1. 6 over 1. Now we can do keep, change, flip. Keep, change, flip. What do I keep here? 6 over 1 stays the same. What do I change? Good. Division changes to multiplication. And what do I flip this to become? 5 over 4. Now that we have multiplication, we can just go straight across. What is 6 times 5? 30. What is 1 times 4? 4. So we have 34, but we're not completely done here. We can simplify. Because my top number, my numerator, is bigger than my bottom number, we just divide. 30 divided by 4. Does 4 go into 3? Yeah? No. 4 goes into not 3, but 4 goes into 30. How many times? 7 times. Good. What do you put under here? 28. We can subtract and you get 2. So we have 7 as our whole number, right? Yeah. 7 is our whole number. 2 that's remaining, that's left over, becomes our numerator, and our 4 that we divided by is our denominator. But we're not done. You can still simplify more. 7 stays the same. The 2/4. What number goes into both 2 and 4? 2. So we can divide by 2. Our 7 stays the same. What is 2 divided by 2? 1. And 4 divided by 2? 2. So our fraction is 7.5. Okay? That's our fraction, but we need to change it. Huh? Because we're dividing. We gotta divide it first. Okay. Yeah, did they hang up? Yeah, that happens a lot. Yeah. So we have our fraction here, 7.5. We need to change it to a decimal and a percent. But now, we already kind of started the division, right, up here. So we might as well. Oh, man. I find it awfully suspicious that we just got a call and you went over there and now all of a sudden it's gone. I don't know. Oh, there we go.
Hello.
Are we back? All good, guys?
Yeah.
Yes, no, I'm back. We're good. You guys can see me. All right, I'm taking that as a yes. Okay, so let's keep going. We can just finish our division here on this first one to make it a decimal. We have 4 going into 2, but drop down our 0. 4 goes into 20. How many times? 5. So our decimal is 7 5/10, right? 7 1/2, 7 1/2. Now, we probably could have. Now we have 7.5, 7 5/10. We need to make this a percent. We need to take our decimal and move it 2 places, always twice. Which way? To the right or the left? To the right, twice. 1, 2. What do I add in this place value? 0. So it is 750% on that one. Yes, you can have 750%. No, you can go over 100%. It just means that you're doing things at higher percentages. You can go over 100%, yes. Yeah. So you can go over 100% for sure. And finally, number 4. We have 3 times 3 times 3 times 3. We need to write this with an exponent. What is the base? What's the big number? 3. We are taking 3 and multiplying it together how many times? 4. So 4 is your exponent. 3 to the 4th power. All right. Now, we don't need it anymore today, so that's fine. Okay, well, you don't need it today, so put it away for now. All right. So we, that's a warm up. I'm assuming they can hear me, although nobody answered me when I asked if they could, but I assume that they can. Can you hear me? Yeah. Yep, we're good. All right, so I'm going to share my screen on Google Classroom. We had a set of notes post. It's not one that you guys are going to be able to type into. I know, sorry, but we're going to review it today. But there's not going to be an assignment or anything, so we're going to review it, talk about the standard that we're going to do this week, and then math will be actually over for the day. It's a quick lesson. I mean, it's kind of a longer presentation, so in math, it was called Combining Like Terms Notes. It's not an assignment that you can turn in. It's just some material that you need. No, those of you here, you don't need to go on it. It's going to be up here. You'll be fine. Yeah, that's why I said you don't need your computers today. So I'm going to get it opened up. And honestly, all you need to do is just kind of follow along and pay attention for the day. You don't need to have it open on your own, but this will be there for you guys if you need it. But if you don't need it, awesome. But it's there if you ever want to go back and reread something or figure out something. So we're going to talk about combining like terms. Last week we talked about what a term is. It's the things that are separated by addition and subtraction signs. So if you have, Okay. So if you have something like 8x plus 4 plus 3y, you have 3 terms here. 8x is a term, 4 is a term, and 3y is a term. So we're going to learn how we can combine these things together to make shorter expressions. Okay, that's basically what this week is. When you combine things together and make it shorter, it's called an equivalent expression. So we're going to talk about equivalent expressions as well. What does the word equivalent mean? We've heard it before. Equal. Equivalent means equal. So the expressions will equal the same thing. They just look different, right? Just like how there's equivalent fractions. 1/2 is equivalent to 2/4, 4/8, 3/6, something that simplifies, right? Very similar to that. We're just going to throw in some algebra Because why not? So let's review a little bit. It's getting hard to talk with this thing on. A constant is the number that's being added or subtracted with nothing else attached to it. In this example, 4 is your constant. It's all alone, no variable, just the number, right? Okay? So that's our constant. Our next one is our variable. We've talked about what a variable is. It's an unknown number, something that we can plug in at any point. Yes, Charlie?
I don't want to make the constant look like a better example.
I don't know how it could be better than that it's a 4.
Because like on here, it just shows like 1, 6, 7, and 9, and 5. It doesn't show like it's like the 3 and the 3 by the 1, 3, 1. Because it's all like the same.
I guess so, but we're also going to talk about the 3 too. So, variables are going to be the letters. They represent unknown numbers. So, X is our variable here on this one. Y is our variable on that one. And keep in mind that they can make variables any letter they want to. It doesn't really matter. It can be a P, an S. X is definitely the most common. X and Y are going to be the most common. The other ones are just kind of like thrown in.
You probably won't see O.
Yeah, you probably won't see an O ever because it could represent a 0, so they won't want you to confuse those terms for. They usually it's like within a word problem. It'll be like someone bought 80 pencils, and then they'll use P as the variable for pencils, right? So they sometimes use the first letter of whatever they're trying to find. So it really depends, but as long as it's a letter, you know it's the variable, right? Alrighty. Next part, the coefficient is the number in front of the variable. We've talked about this quite a few times. Your coefficient is the number that is married to and being multiplied by the variable. So in this case, 8 is married to and being multiplied by the x. There's invisible multiplication here. If you see a dot, it means multiplication. So invisible multiplication is happening between the 8 and the x and the 3 and the y. Okay? So there's our coefficients. I think that's all in terms of that. Now let's talk about like terms. Terms that are the same. In an expression, like terms are terms that have the same exact variable raised to the same exact power or exponent. So these actually don't have any like terms because your variables are not the same. X and Y are not the same letter. You can't combine these variables. If we have something like 2x, well, this is not a marker, 2x plus 3x, you have the same variable and they're raised to the same power. They don't have an exponent, so they're the same. So in order to combine these, you just add 2 plus 3. What is 2 plus 3? 2 plus 3 is not 6. 2 plus 3 is 5. So this becomes a 5, and your x stays the same. There's 5 x's there. That's basically what we're going to do this whole week. Okay? Well, we just started it, so if you're confused, give it a little bit of time. So, like expression or like terms have the same variable raised to the same power. So it could be x squared, x to the third power. They just need to be the same. Okay, so here's a couple of examples. You could have 4x and negative 3x. Oops. They are the same variable raised to the same power. You can combine them together. The next part, you can combine 2y squared and negative y squared because they both have the same variable of y, and they are both raised to the same power too. They look the same. The variables and the exponents are the same. You can combine the numbers in front. Okay? We're going to practice this. I know it's a lot, but we're going to practice it. So it says, like terms usually consist of a variable, x or y or z or whatever a variable they want to use, and some form of coefficients. Could be negative, positive, it doesn't really matter. So they all have the same x, the same variable. They're not raised to any powers, same variable, just x. It does not matter what number is in front of them. The only thing that matters is they have the same exact variable. I'm going to say that like 80 times today. The same exact variable. Okay? So x is the same. We can combine all of these terms if we wanted to. We're not going to yet. Combining them just means you're either going to add or subtract them together. And the x will stay the same. Okay? Like terms. Oh, these ones are all the same because they're constants. So if there are numbers in your expression that don't have variables attached, you can add or subtract them like you would normal numbers. They can be combined just like normal numbers. So this could be 15 minus 2 plus 27 plus 9,043 plus 6/10. But we're not going to add them all up. Okay? No, we don't have time for that. So these are all like terms because they're constants. You can add together the constants. And then these ones are all like terms because they have y to the second power, y squared. You can combine all of these ones because they have the same variable raised to the same exact power, or exponent.
So what would you do? You add all of them?
We're going to talk about it. Okay, unlike terms are ones that do not have the same thing. This is 17x and 17z. The x and the z are not the same letters. They're just unlike. They're not the same. You cannot add or subtract them together. Kind of, yeah. So they're the opposite of like terms. They're unlike. You cannot combine them. Okay, so these have different variables, and because the variables are different, you cannot add or subtract them together. So x is not the same letter as z, so you cannot combine them. These ones all have the same variable y, the letter y, but there's a reason why I cannot combine them together. Anybody want to tell me why? Do they know? They are unlike, but why? The exponents, good. They have the same letter, the y's, 15y, 19y, 31y. But this exponent at the top, the 2 and the 5, technically there's a 1 here, an invisible 1. They are not the same exponent, so you cannot combine them together. They have to have the same exponent as well as letter. Okay? What else we got here? This one, although they both have an x, they're still not the same because that second one, 14xy, has a y attached to it. Can't do that one either. They have to be the exact same thing. All x's, all y's, all z's, something like that. Okay? So let's talk about how to actually combine them. On this one, we have 6x plus 2x. Okay, there's 6 x's in this part and 2 x's on that part. Those are two terms. Are they the same? Are they like terms, basically? Yes. Why? They have the same letter and what? And the same exponent. Technically, it's x to the first power. There's x to the first power. But you don't have to write the first power. So, they have the same exponent and they're the same letter. We can combine them. The way that you combine them is you add together the coefficients, the two numbers in front. So you would add together 6 plus 2. 6 plus 2 is 8. And then the x just stays the same. So you just add together the numbers in front, and then x stays there.
So you say that x equals 6, and then we just add, we do 6 times 8, and we have the expression, and add.
You could, or you could combine the like terms and then do it in one step. Yeah.
So the same answer.
Yeah, you would. Because it would be 36 plus 12, 48. So, combining like terms means that you take the coefficients in front, the red numbers here, 6 and 2, add them together and just carry over the variable. It stays the same. Here's another one. This time there's x's and y's. they start off by showing us that we can combine the 4x and the 2x. But when you talk about these terms, you have to take the sign in front. So this is a 4 minus 2 because it's a subtraction sign. What is 4 minus 2? 2. So you get 2x. And then you have your y's. You can combine the two y's together. This is a positive 3 plus 4. 3 plus 4 is 7. That's where they get 7y. So you're just adding and subtracting these numbers together, and the variable stays the same once you're done adding and subtracting them. Okay, you can never, should I say never again? They have a lot of nevers. Never combine the x's and the y's together if they're not the same. You just can't do it. You can't suddenly take 2x plus 7y and make it 9xy. It does not come out to the same answer. They're not equivalent expressions. Yes, Alex. What? I don't know how to fix that. Maybe log out and log back in. Yeah, oh yeah, I guess you can't hear me. Yeah. All right. And then that other example there says 3a plus 6. You cannot add together 3 plus 6 and get 9 and then just throw the a at the end because there's no a on the 6. Okay? All right. Well, they really wanted to emphasize that. So, it's like taking cats and dogs. You can add together that there's 5 cats plus 3 cats, and how many cats total are you going to have? 8 cats. Super easy, right? You can replace cats with the variable c and say 5c plus 3c equals 8c. Yep, just like what they...
12 cats.
No, it's not. It's 8 cats, Mrs. Stacy. Minus 1 giraffe. Oh my gosh. I wasn't prepared. All right. So this one would be like 5 Americas plus 3 Americas equals 8 Americas. They're apples too. It's the same thing. You can add them together. Good. Okay, focus back up. The next one is opposite ones. Can we add together apples and oranges? Nope, they are different things. I did not choose these pictures. They are scary. I apologize. I don't know. But if you consider apples and oranges, they are not the same thing. You cannot add together 5 apples plus 5 oranges. Not a thing. Okay? It's like taking cats and dogs. You can't combine them either. 5 cats plus 3 dogs does not suddenly equal 8 cat dogs. Have you guys ever seen that show? No? Yes? Cat dog? Never seen that? Okay. There's not actual cat dogs in real life, so you can't add together cat dogs like that. No, because they're different. Yeah. Okay, so cats and dogs are different things. You can't add them together. So now let's try this. Oh boy, that's a long one. Let's do it on the board behind me. So focus on the board behind me and let's talk this through. Can you guys see it all right?
Yeah.
Okay. No? Guys, laptop's closed. I'll talk to you about that already. Focus up here. Okay, we have 3y plus 2 plus 3x minus y plus 5x, right? Yeah. All right. So let's talk about this in terms of like terms. We need to find the ones that we can add or subtract together. So let's start with 3y. Is there a term that I can add or subtract with 3y?
No.
Yeah.
There is. What is it? The like term. So which one's the like term? The y. You need to look for another y, and you take the sign in front of it. But now this is just a y. What coefficient goes in front of it? No. 1. This is a 1y. Minus 1y. Okay?
Still can't hear.
Check his volume.
Vistophanes, got it, just focus up here. Okay, so this would be 3y minus 1y. But before we do that, let's just finish combining some other things.
Okay.
Let's look at the 2. This is a constant. Is there another constant that we can add or subtract with it? Do you see anything else that's just a number by itself?
Yeah.
No. Nope. So that one's all by itself. It's just a positive 2. Then we have 3x here. I'm going to do a triangle this time. 3x. Remember, you got to take the sign in front of it. So this is a positive 3. Is there something I can combine with the 3x? The 5x. It's the same thing. You have an x. Okay. Now let's do our math. This is 3y minus 1y. How many y's are you going to have? 2 y's. You just do 3 minus 1. Carry your variable. So we've used our y's. Okay, let's do the 2. Is there anything to add or subtract with the 2? Nope. So we just drop it down as part of our equation. Then we have our positive 3x plus 5x. So we're going to take 3 plus 5. What do we get? 8. And then you carry over your x. We don't know yet. So,
Wait, so you can just add like using the line to pretend it's not there?
yeah. And then you just make sure you attach it at the end. So now, if they were to give us like y equals 4 and x equals 2, we could figure what this is out. We're not going to. We don't have to just yet. We will later, but we could if we wanted to. Right now, we're just practicing how to combine these things together. Okay? But later in your math career, probably 7th and 8th grade, they're going to tell you what x and y equals and make you solve these things out and all of that. Maybe even later in this year. So, let's look, see if we did this right. How much time do we have?
8 minutes.
Okay. Do you guys feel like that was a lot of information?
Yeah, I'm still on.
Okay. What about online? Do you guys feel like that was a lot of information?
Yes,
Yes, ma'am.
Okay.
Supposed to say yes, ma'am, instead of yes, sir. Supposed to say that in the man, not.
Yes, no. Are we still there online?
I don't think they can hear you.
No, they can hear me.
I feel like none of them are even at the computers.
I mean, it's a possibility.
I would have been making risks in my now.
All right. So Phil is there. Olivia's got to go. That's fine, Olivia. Well, I think so that was a lot of information, and before I throw more at you, I think we're gonna stop there and we'll pick it up tomorrow before I give you like more, because that's a lot. So I think what we're gonna do is just practice a couple more. I'll put some up on the board behind me and have you guys practice maybe 2 or 3 before. What? Sure. So let's just do a couple of practice. I'm gonna stop presenting and put this up a little bit higher. And then we're gonna do maybe like 2 or 3 together, and then we'll be done for the day. So,
We're done for the day, please.
for math, let's do big jacket. Let's take 4y plus 3x minus 2y plus 8x. Okay, so we have these x's and these y's. Let's do one together. I'm gonna have you do one on your own, okay? Let's look at our y's first. Okay, let's start with positive 4y. Is there something that can combine with this y? What can? This 2y, right? But you got to make sure you take the negative in front of it. So y and y. Okay? We could solve it right now really quick, right? What is 4y minus 2y going to be? 2y. So you do 4 minus 2, and then bring the y with it. 2y. Then we have x's. We have 3x here. What can I combine with the 3x? The 8x, and it's a positive 8x, so we're gonna add. What is positive 3 plus 8? 3 plus 8? 11. And then what variable attaches to it? X. We'll do that later, not right now. Okay? So there's one practice. I'm gonna give you one. I want you guys to give you for now, yeah. All we're doing is simplifying it. So we're making it equivalent expressions. So these two expressions are equivalent or equal, right? We've been talking about equivalent expressions a little bit. So if I were to plug in numbers for the y and the x's, if I gave you those, and you solved this one and did all the work for this one, you should get the same exact answer as if you did it with this one too. Okay.
Can we do that like just variables? No.
Yeah, let's do it with 3 variables. Why not? We did it kind of with 3 variables because we did it with a constant. So let's try 4x plus 3 minus 2 plus 7x plus 3y. That sounds good. Lots of numbers there, right? So, okay. Let's start with the x's. So we have 4x here. What can be combined with it? 7x. It's the same. 7x. Good. Let's go to our 3. This is just a constant, just a number, a positive 3. What number can be combined with the positive 3? The 2, but it's a subtracting 2, right? And then we have that 3y on the end. Is there anything to combine it with?
No.
No, but it is on its own, so we're going to show it like that. I use shapes usually to do this because I don't have enough colors to do it, so I like to draw shapes around the ones that are combined together. It makes it a little bit easier to keep track of. So let's do 4x. What is 4 plus 7? 11x. Now we did the x's. Let's do the constants. What is 3 minus 2? 3 minus 2 is 1. Say positive 1, right? And then we can drop down our 3y plus 3y. There's our answer. Let's do one more with lots of variables in it. We'll try that. We'll do 3. Well, you're not going to see more than 3 variables usually anyway, so let's do 8y minus 3x plus 4z minus 3y minus 6x plus 3z. Lots of things there, right?
Oh, yeah.
This is a long one, right? So let's start with the y's. 8y. Let's start with boxes around the y's. What can I combine with the 8y? Just 3y? Good. Don't forget the sign in front. This is minus 3y. Good. Now let's look at our x's. We have negative 3x. This is going to have some negatives in it, so it'll be fun. We have a negative 3x here. Which one can I combine with it? Good, the negative 6x. This is a negative 3. We got to subtract 6 from it. We'll talk about it, don't worry. And then we have 4z. I'm going to do a triangle. This is a positive 4z. Which one combines with it? The 3z. All right. Let's start with the y's because they're here first. What's 8 minus 3? 5. So we have 5y. Okay. Right. Our next one is negative 3 minus 6. This brings in our negatives. Let me see if I can get this up high enough so where they can see the thing. If we're at negative 3 and I subtract 6, am I going to go to the right or the left? The left. 6 times. 1, 2, 3, 4, 5, 6. I know. But you get negative what? Negative 9. Okay, because -3 minus 6 is -9. What variable attaches to that? X. So we did the x's. Now we can do the z's. We have a +4 plus 3. So what's 4 plus 3? 7 z. So you just got to be careful. Take the time to figure out what? I don't know. That's how I write my z's. Yeah. Sorry.
Just one way, Charlie.
All right. Yes, that's a longer one. Probably the longest types of ones you'll see. But my biggest advice is to do these shapes or use different highlighters to make sure that you're getting all of the terms that you need to add or subtract together. Sometimes it gets longer. Sometimes you have like 4 that you need to add or subtract together. So just take the time to identify the like terms and take the time to add or subtract correctly, because you are going to end up with the negatives and stuff. So you want to make sure that you're using your number lines and doing the negatives correctly. It's a big part of it. Okay? Other than that, we will talk more about it tomorrow. I don't want to overwhelm you guys today. There's a lot more to, not a lot, but there's a little bit more to talk about with this. We're going to throw in the distribution.